I will be recording this for my portfolio and just a practice afterwards. So your faces and nothing will be recorded, obviously, but just in case, please do mute your mic and turn off your video. So to get into the presentation, so I am focusing on predicting fantasy football points using regression analysis. All right, as far as why you ask I'm doing this, well, because like many of us, or maybe some of us, don't play fantasy sports, and you will learn obviously a lot about it today. But a lot of times it's very frustrating because you don't know how many points your team's going to put up or your player's going to put up. He could have put up 30 points last week, then all of a sudden he just put up a dud this week. So I thought, okay, well, why not utilize data and then different types of regression such as linear, polynomial, lasso, and ridge to predict how many points will a running back and wide receiver have in the next game based on statistics from the previous game. So my target audience I'm really looking at are fantasy football players and NFL statistics enthusiasts. All right, so as far as the data goes, there's tons and tons of data out there. So I really just want to focus on one season, so 2019 last year, and then just running back and wide receivers as of right now, just to build out my model. And a great resource is Pro Football Reference. So as far as what I'd be looking for are the coefficient determination, so my R square, so essentially showing your correlation between your dependent and independent variables. So your dependent variable being fantasy football points, independent variables being rushing yards, receiving yards, touchdowns, etc. And you want to have that as high as possible, so as close to 1 as possible, and that's a good model, typically. And then you want to minimize your root mean square error, so that means in this case, you want to have the points as close to the fantasy football points as possible, so plus or minus 5, 6, etc. So as far as the players go, if you look down at the bottom, I was just focusing on receivers and running backs above or around 500 yards, and then 16 games or whatever games they played due to injury, and then that gave me my rows of data. All right, so just focusing on this is obviously there's a lot going on here. So these are potential features, and as you can see, the target variable in the middle, those are my fantasy points. That's what we are going after, and that's what we're trying to predict. However, you could look at carries, rushing touchdowns, receiving yards, yards per carry, targets, etc. So with the modeling and then the help with lasso and ridge regression, we're going to narrow that down and then hopefully get a more precise model. All right, again, just showing the features correlation heat map, which this is showing the correlation between each feature, really focusing on fantasy points and then how everything else is correlated. Again, it's just a lot going on. We really want to minimize that, and I really wanted to have a graphical representation of this so you guys, the audience, understood, okay, what are we working with, what are we starting out as, and what are we going to? So as far as I looked into lasso, ridge, linear, and polynomial, you see, and then I really ultimately decided to go with linear regression for at least this model. And the reason being the R square was a little bit higher, a little better than the rest. And I kind of figured with the other two models, at least ridge and lasso, I can incorporate that into linear regression as well as far as feature selection goes. So when I initially plotted everything, and this is strictly just for running backs, so we want all those dots closer to the line. As you can see, they're a little scattered. On the x-axis, they're a little more clustered between the 6 and 16, but then on the y-axis, they're kind of all over the place, and this is the actual versus predicted for my running back. So it's essentially showing you, okay, how well did the model do? So I would say this is okay, and obviously much room for improvement. Wide receivers, that line just does not look great, so obviously room for improvement there, but this is something that we can work with. And again, as you can see, this is just a little bit more spread out than the last. So now just to give a little bit of a visual representation as far as, okay, what do all these dots, what does this mean? So predicted versus actual comparison between running backs. So if you focus on the delta, there's a lot going on here as far as numbers and whatnot. Just focus on the delta all the way on the right, and that tells you between the tested fantasy points and the predicted fantasy points, which was built off my model, how each player fared. So with Derrick Henry, some weeks he's going to put up 39 points, and then other weeks he puts up about 10. So those weeks, it's a huge discrepancy. And the main other thing that you should really focus on is the average delta down at the bottom, which is basically the difference between actual and then predicted was about 9 points. So it's quite a big variance and definitely room for improvement there. And then wide receivers, same thing, focus on the green, the delta. And so you can see it varies all over the place. For example, Keenan Allen, my model got it very closely within 0.46, but then other days, Keenan Allen had 20.99 points. So again, the delta here was 1.32, and then I want you to hold on to that number because I'm going to refer to that here in the next slide in a second. So as far as final features go, I was able to do feature selection utilizing lasso and regression. And so that really showed me, okay, what features do I really need and what features do I really not need. As you can see, there's a little bit more cleaned up, and then we can potentially minimize those a little bit more. So in conclusion, I'm really looking at my RSME, my root square mean error, and so how many points am I in within the actual. So for running backs, I was within 7.5, and for wide receivers, I was within 6.76. As you remember from the previous example of 1.3, so this is indicative that my wide receiver modeling set probably needs a little bit more work. Then obviously the running back set does as well, but the average is closer of the 8.9 to this 7.57 of plus or minus 100 points. Future iterations, so I had my model working off of a running average, but now I'm going to do a 4-week running average, and that's a strategy that I actually typically take, because just because a running back or wide receiver did well in week 1 does not mean he will do well in week 17. It may not even be correlating. And then the biggest thing is incorporating the defensive statistics, because depending on who you play, that is going to impact your game. And the biggest thing I want to do is compare it to other linear regression models by Yahoo and ESPN. And that is it. Any questions?